Hey, ladies and gentlemen. So, real quick. So, we're going to be looking at Lewis dot structures again. Okay. So, the first thing we need to do is remember Lewis dot structures only look at two things, our valence electrons and our element symbol. Okay. So, the valence electrons, how many valence electrons do all elements want to have? Remember, or almost all elements. Okay. That key word right there is almost. And it's a key word because remember, there are a couple exceptions to our rule. Okay, but for the most part, once we get past that first ring, right, of our after our nucleus in the middle, in our first ring of electrons, our second and our third and our fourth ring can all have a maximum of 8 valence electrons. All right, remember they can't have any more than 8 valence electrons. Once we get to 8, we are done for sure. All right, then it resets at 0 again when we get to the next line, when we go to our next ring around the nucleus. All right, the next one. All right, what are the two elements that are the exception to that rule? The two elements are going to be hydrogen and helium. All right, and why are those two the only ones? All right, if we remember, all right, the hydrogen and helium only have the first ring, which means if we look on our periodic table, they only go across that first row, and we only have the two elements in that row, which means it gets a maximum of 2 valence electrons, not 8. All right, so 2 valence electrons. All right, and so let's go through a couple, all right, just to look at them. All right. So if we were going through, right, the first one is hydrogen. Hydrogen is the element symbol H, and it actually is in the first row. And it's so that means it's got one orbital because it's in the first row. Remember, this is our row number. And the number of valence electrons, it's in that first column, which means it also has one. All right. So our Lewis dot structure, remember, has the two parts: our element symbol and valence electrons. Okay, so our element symbol for this one, right, for hydrogen is H. So we can draw an H. And because it's got one valence electron, we just put one somewhere on our element. All right, so I'm just going to put it right there. All right. Next, okay, so if we wanted to go and look at this box, okay, this is to get a full shell. Remember, hydrogen is one of our exceptions, right? Hydrogen is one of those exceptions where it only needs 2 valence electrons. So this one, if we had one, it only needs 2. 1 plus what number gives us 2? 1 plus 1 gives us 2. So we need one more in order to have a full shell. And if we lost one, our shell will be empty, which is the other option. Okay, so this one, we want a full shell or a full orbital. And in this one, we want an empty shell or an empty orbital. Okay, so we gain one, we have a full one, we lost one, we'd be empty. Let's look at lithium and just do it one more time together. Okay, lithium, we look, lithium's actually Li on the periodic table. Again, it's in the first column, but this time it's not in the first row, it's in the second row. It's element number 3. So lithium is in the second row, which means it's an orbital, has how many? It's got 2 orbitals because it's in that second row. Right? But again, it's still in that first column of our periodic table. And if it's in the first column, it still only gets 1 valence electron, just like hydrogen only gets 1 valence electron. All right, so lithium, again, is Li. And since it's only got 1 valence electron, we only put 1 dot on our element. And we're good. But unlike before, lithium is like the rest of them, where it needs a full 8 in order to be happy. So if we need to get to 8 from 1, 1 plus what number gives us 8? So we need to do, and if we do our math, we do 8 minus 1, and that's going to be how many we need left, which is 7. So we need 7 more to get to our full shell here. But if we want an empty shell, we would only have to lose the 1, since it only has one valence electron. We'd only have to lose the 1 valence electron. Okay. A lot of the other metals are going to be very similar. And so our metals are anything on the left side of the periodic table. I do want to just look at one that's a little bit more difficult. Okay. So if we look all the way down, let's go to nitrogen way down here. It's the second to last one. So nitrogen is going to be the element symbol N. And just like before, we want to know what is the row that nitrogen's in, or how many rings or orbitals does nitrogen have. And if we look, nitrogen is in our second row, and this is number 7, so it's in our second row, just like lithium was. So we put a 2 here for our orbital. And the number of valence electrons. Remember, we count only the top 8 columns. So if we go from lithium to beryllium, that's 1, 2. We go all the way across to boron, which is 3, carbon, which is 4, and nitrogen, which gives us our total of 5 valence electrons. So nitrogen has 5 of them. So now it gets a little bit trickier when we draw it, because we always want to do the same kind of thing every time. We're going to start on the top, and we put 1 here. We want to kind of follow along like a compass almost. So we start up in the north, and then we're going to go east. So we're going to go to the right, 2. Then we're going to go south. We're going to go to the bottom for 3. Then we're going to go west. We're going to go back up here for 4. And then we're going to start doubling up. All right. So then this will become 5. And then we're done because we only needed those 5 valence electrons. So we only put the 5 dots. Okay, now that we have that, and again, nitrogen is not one of the only 2 special ones that only need 2. So nitrogen needs how many? Nitrogen needs 8 valence electrons. So it needs 8. Oh, too large. It needs 8 valence electrons. It has 5. So we need to take how many are missing? It's missing 3, which means it needs 3 more. In order to be full. To be empty, it would have to lose 5. Okay, so we either need to gain 3 or to lose 5 in order to be happy. So I want to go to number 4. I want you guys to do number 3 on your own. All right. So think back to the FET. What did they call it when it was not when it had a positive or a negative charge, when it lost or it didn't have enough electrons to match the number of protons? So when protons and electrons had different amounts. Okay, so we want to know what it's called when they had different amounts for number 3. Number 4 wants us to look back up at all of the ones that you've done. So you'd go and do all of them, but we only did 3 together. So we're going to look at those 3. Okay, so we need to see which one is going to be the quicker one to do, to try and have a full shell to gain more or to lose more. Okay, when we're doing this, we need to remember one thing. Okay, those electrons have to go somewhere or they have to come from somewhere. All right, so they can't just magically appear and just exist now. All right, they have to be taken from a different element or we have to give them to a different element. All right, so there has to be something else around who's gonna have the opposite effect. Okay, so we look at the first one, hydrogen. Hydrogen's kind of in the middle, and so we're actually not going to circle one for the ones in the middle. Those ones are going to be a little more up for grabs. They can go either way. They're willing to gain electrons. They're willing to lose electrons. It just depends on who's around to take them or to give them away. If we look at lithium though, okay, lithium's got 7 that it needs to take from somebody else, or it's got 1 that it needs to give away. All right. So going around, is it going to be easier to go and find 7 more things to take away from other elements? Or is it easier just to give one away and then just be done with it? Okay. Because we don't actually need it. So because we're just going to look for the bigger number. Okay. Lithium is 7 is the bigger number. So we're going to ignore that. We want the one that's smaller. Okay. So this one is going to be what we're going to do. So lithium would lose electrons because it doesn't need that 1. It'd rather have an empty shell than have 1 in it, because it'd rather have none than it have just 1 that's kind of dragging it along and it's holding it back to do all its good things, like being those batteries we were talking about. Okay. We look at nitrogen though, nitrogen's the opposite effect, right? Nitrogen only needs to find 3 elements to take electrons from, but it has to find 5 different elements to give its electrons away. So it's not going to find and have an easy time to find 5 different elements rather than 3, right? It's easier to find 3 than it is to find 5, because you have to at least find 3 either way. But then with 5, you need 2 extra ones after that. That's a lot more work. So it's going to just take some electrons from other elements, because that's a little bit easier to take 3 than it is to find 5 new elements to give its electrons away. So this one is going to be what it ends up doing, because 3 is a smaller number. So 3 is easier to do, right? So 3 is going to be just a faster way of doing it than trying to go and find 5 and then work our way through 5 different elements to find all at once. Finding 3 all at once is a little bit easier. Okay, so you're doing the same thing for all the other ones in that table above. You're just going to trying to decide, is it going to gain electrons or lose electrons? Okay, so once you do that, okay, so the ones that are going to be up in the air, we can kind of just ignore. All right. Or we can do it both ways. So we can kind of split this one up into 2 parts, right? So hydrogen, it's element number 1 on the periodic table, which means it's got 1 proton. Normally it has 1 electron. So we're going to put 1. But if it gains another electron, right? That first column is gaining electrons. We gain 1, which means it would have 2 electrons. Okay. So now, if hydrogen gained 1 electron, remember electrons are negative charges. Okay, so if it's a negative charge, that means it's going to become negative when it's getting an electron. I know it's a little backwards from what adding means to us normally, but when we add an electron, we're adding a negative charge, right? So hydrogen went from having 1 electron, now hydrogen has 2 electrons. And if it has 2 electrons, it has a -1 charge. Okay, but remember, hydrogen can go both ways. So if hydrogen started with 1, remember this is our start. This is gaining 1. Now, if hydrogen started with 1, and it lost 1, it would have 0. So that means hydrogen, that dot that it had, that electron it had, goes away, right? It's gone. And now, because it's gone, it doesn't have that electron. So now it has more protons. So now it's a more positive. So it's got a +1. Okay. Again, this is again our starting. This time we lost one electron. Let's put electron there so we remember it's lost an electron. All right, which means it lost or gained a negative charge, which is why we're getting more positive or more negative, right? Again, if we think about hydrogen, we have one positive and then we'd have two negatives on this side. So these guys cancel and we're left with an extra negative charge that wasn't there before, right? If we think about this one, we'd have zero negatives. So then we still have that extra positive charge that isn't being balanced out. And that's how we got to this guy, right? Again, let's look at lithium because we did lithium as well. Lithium is element number 3 on the periodic table, which means it has 3 protons. Lithium only got one option because if we look back up here, lithium either had to gain 7 or lose 1. And so it's easier just to get rid of that 1. So we don't even have to worry about the 7. We could cross this out if we want. Forget about that one. Doesn't exist to us anymore. All right. So lithium had 3 electrons because remember, our protons and electrons are always the same amount to start. We lost 1. So now we only have 2. All right. And because we lost 1 and lithium started as Li with its valence electron up here, because we lost that one, right? It turned in to Li with a +1 charge. Because remember, lithium has 3 positive charges, and now it only has 2 negative charges. And so we have an extra positive charge that isn't being used up, which is where this extra positive charge comes from. All right. One last time, let's look at nitrogen, just because we've done nitrogen before. Okay. Nitrogen is number 7 on the periodic table. So we're going to look at nitrogen. We're going to put number 7 on the periodic table. So it's got 7 protons. If it has 7 protons, it started with 7 electrons. And if we look up at nitrogen up here, remember the one that's smaller is the one we care about. And so this time it's 3 because it only needed to find 3 electrons to bring in rather than try and get rid of 5. So again, we're going to ignore that 5. It doesn't exist to us anymore. Only the 3 matters. Okay, so we need to gain 3. Remember, gaining 3 means we add 3 electrons. So now we have a total of 10. And if we wanted to do our charge, remember charge equals protons minus electrons. So charge equaled our 7 minus our 10. So we end up with a -3 charge, which is how we're going to get that over here. But remember, nitrogen started out with N and it had 1, 2, 3, 4, 5 electrons to begin with. But because we added 3 more, we add 1, 2, 3 to fill in all the gaps. And because we're filling in all the gaps, it gets this -3 charge with the 3 extra electrons. So we put a -3 up here to remind ourselves it's got a -3 charge. Okay. If you have any questions, let me know or check the answer key. And then have a great rest of your day. Finish up this worksheet, keep working on it. And if you have questions, again, please do ask.